All right, people. Toolkit number 18, cruising along. We're going to do transformations of sine and cosine. Okay, we're gonna take that from like parent functions, right? Think about parent functions that we did a long time ago, and we're gonna do things like shift them to the left or the right, or shift them up or down. We could stretch it out. We could squish it in. We could stretch it out this way. We could squish it in this way, right? So those are the transformations that we're going to learn how to do here for our sine and our cosine graphs. Okay, that's the idea here. All right, so here's what A tells us. The absolute value of A is amplitude. Okay, so if we have a sine curve like this would be more amplitude. More amplitude. Okay. Think about what an amp does for a speaker, right? If you have a bigger amp, it makes more sound, right? Think about, have you ever seen one of those like you're looking at music, right? And it's these sound waves, right? Well, if it gets louder, those waves get bigger, right? That's amplitude, right? If the amplitude shrinks, it's getting softer, right? All right. If our A value is negative, so if it's negative 2 sine of something, or if it's negative sine of something, right? What did we do before when that multiplier was negative, right? We flipped it. We flipped the graph over the x-axis, up and down, right? So amplitude makes things stretch or squish in the up or down direction. A negative A value would flip things in that up and down direction. All right. We'll take a wild guess what the multiplier next to the x would do. Okay. What is that going to do? Well, it's going to be in the x and y direction. It's either going to squish things or stretch things. If b is negative, guess what it's going to do? It's going to flip it side to side. So if b is negative, it's going to flip side to side. B tells us how squishy it is. And in trigonometry, we call it a period. So period is how long something takes, right? The period that you're going to be in tomorrow at school could be an hour, could be an hour, 15 minutes, could be 50 minutes, right? It's how long it takes from beginning to end. Okay. So period is distance between beginning and end. And we actually have of one, the start from start to finish, right? Beginning to end. For us, period, for sine and cosine is equal to 2 pi over whatever b is. Usually for us, what we've done so far is b is 1, right? So what number is in front of that x? A 1, right? 2 pi over 1 is 2 pi. This started and then finished in 2 pi. So it took 2 pi for it to go through one full cycle, right? Same thing with cosine. Cosine's full cycle goes from the top down to the bottom, back to the top again. Its period was 2 pi, right? This is a 1 in front of the x. Okay, 2 pi divided by 1 is 2 pi. So this doesn't change. It's kind of its normal parent self thingy. But if this was cosine of 2x, we would go 2 pi divided by 2, which would be pi, which would mean it would start and then finish by the time it got to pi. Okay, so kind of cool. Here we go. So 2 pi over b is the period, and we're going to practice that and we'll get better at it and you get used to it. So we're going to start with just the multiplier on the outside. That's so nice. Thanks, Mr. Rebuff. This means the amplitude is equal to 2. There's no flip. Okay, but we go up to 2. So let's do it. So if this was our 1 before, we'll keep that and we'll go up to 2. It also means in the negative direction, it's going to go down to where? If you said negative 2, you're right. This is a sine graph. Um, we'll make that pi. We'll make this 2 pi. Okay, so I went over 4 for pi, over 4 for 2 pi. All right, do you remember for sine, the 5 dots, where the first 3 go? Right on the line, right? Nothing's happened to move it up or down. So we're going boom, 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 right? Ordinarily, we would go up to 1, and go down to here. So the parent graph, I'm going to dot in like this. So that's the parent graph. But what does this mean? The amplitude is 2. We're stretching it. We're doubling how high it goes. So take a wild guess what its new high point is going to be. Yeah, amplitude is 2, right? So it's going to go up to 2. It's going to go down to -2. And now I can graph it. Oops, didn't quite go through the point, so I'll make the point a little there. All right, notice amplitude. Is amplitude the distance from the high to the low? Mm-mm. Amplitude is the distance from the middle to the top or from the middle to the low. So this is amplitude equals 2. This is amplitude equals 2. So from the middle to the high or the middle to the low. So how far is it going from the middle? That's your amplitude. It's not from the top to the bottom. It's half of that. Okay. But that can be something that people mess up sometimes. All right, here we go. -3 cosine. Well, the negative means we are going to flip it. We are going to flip it this way. The 3, well, we could do absolute value of 3 equals +3 is equal to the amplitude. So the amplitude is equal to 3. So the distance from the middle to the high and middle to the low is 3. This is a cosine graph. Okay, cosine graph. So let's draw its natural thing. Now, I don't have enough room to go by twos, I don't think. So I guess I have to make this 1 and this -1. Is that okay? And then 1, 2, 3, 4 is pi. 1, 2, 3, 4 is 2 pi. And here we go. If the amplitude is 3, right? It's going to get how high? It's going to get up to 3. How low is it going to go? It's going to get down to -3, right? All right, so let's draw the normal cosine graph. Normally, cosine would go through 1, 0, -1, 0, +1. I'm going to do a little dotted line, right, for our usual cosine. But two things are going to happen. What are the two things? It's flipping. So it's going to actually start low and then go to its high and then go back to its low. And it's also getting hit with 3 times the amplitude, right? So it's not going to start at -1. It's going to start at -3, right? It's going to end at -3. Halfway in between, it's going to get its high point right there. And now we can complete that V. It's going to go through this point and this point, midline, right? So let's go ahead and fill that out. There we go. Easy peasy. Lemon squeezy. I always think this looks like a ghost or something or a happy grimace. Yeah. All right. Cool, 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 cool. All right. So this has a flip up and down. Okay. And it's got a period shift. So period for this one is equal to 2 pi. It's always 2 pi for sine and cosine. It's 2 pi divided by whatever's in front of that x, 2. So my period is going to be equal to pi. Ooh, okay, cool. All right. And the other thing is we are flipping. So here we go. Let's go. Nothing else is happening. So I'm going to make this the 1 again and this the -1 again. I'm going to make this pi and I'm going to make this 2 pi. Now I could change the scale if I want to, but I'm not going to because I kind of want to see how it changes compared to the 1 above it. All right. So what does a 2 do on the outside compared to the 2 doing on the inside? They do different things. One stretches this way. One's going to actually squish it this way. You're going to see it. It's going to be cool. All right. So the period is pi. Okay. This would usually start in the middle, right? It would usually end at 2 pi, but now it's going to end at pi. So the 3 dots have to be beginning, end, and then halfway in between. So those are my 3 dots now. See how it's squished over from up here. Okay. The other thing that's happening is we're flipping. Instead of going up first and then down, we're going to go down first. So it's going to hit its -1 first. Then it's going to get its +1 here. So this will look like this. Cool. Yeah. Right. So we flipped it. Ordinarily, we would look like this. Okay, that's the parent function there. We've flipped over and we've squished. Or you could think of it as we've squished over, we've cut in half, and now we've flipped over. Cool. All right, here we go. Last one. 2 cosine of pi. Oh, whoa, that's going to be funky. It's always funky when that happens. So this means amplitude is 2. It's positive, so it's going to stay the same, right? But the amplitude is 2. So that means without anything else going on, we're going to go between positive 2 and negative 2. Cool. So our high point's going to be 2. Our low point's going to be negative 2. The period, though, is equal to 2 pi over whatever's in front of x. Pi. Ooh, what's canceling here? There's no more pi. It's the number 2. That's crazy. Well, if that's the case, I'm going to use this. If this distance was 2, let's just have some fun and make this distance 2. I guess we could. Let's go. There's 2. Oh, does that match? Yeah, because these are 1, 2, 1, 2. All right, that'll work. It doesn't look like a box, though. I think this graph got squished or something. All right. So for cosines, we start high. This one has not been flipped, so it's going to start high. It's going to end high. It's going to end at 2. So start high, end high. What happens halfway in between? Low point. There we go. What happens in between the high and the low? Middle point. High and low, middle point. And do we have enough to graph it now? Yeah, we've got our V. Got our cool V. There it is. Not bad, not bad. To me, this looks like a reindeer. I don't know how to make it more reindeerish, but it looks like a reindeer. That's it. That's it. Sines, cosines, we're transforming. So we're just working on squishes and stretches, right? We introduced something called the period here. That's how long it takes to go through one complete cycle of something, which makes sense. And that's that. Enjoy. Oh, so happy. See ya.